Hi everybody, welcome to a video on the cardiac cycle. I'm going to get straight into it and make this as concise as I can and hopefully teach you something about it. If you have any questions, please leave them in the comment section below and I will get back to you as soon as I can. So, what is the cardiac cycle? The events that take place between the beginning of one heartbeat to the beginning of the next is known as the cardiac cycle. Cardiac cycle duration is equal to one heartbeat. So I'm just going to pop a definition here in the screen. What generates each cycle? There is a generation of an electrical impulse known as an action potential in the sinus node, which consists of a group of cells known as the natural pacemaker cells of the heart. The sinus node is located in the right atrium on the posterolateral wall near the superior vena cava. The impulse is spread from the SA node to the AV node but is not instantly spread. Because of how the electrical conducting fibres are arranged, there is a small delay of about 0.1 seconds for the impulse to spread from the atria to the ventricles. The two main phases of the cardiac cycle are known as diastole and systole. Diastole is a period of relaxation where the heart is filling with blood. And as you can see here from my pointer, diastole is the longer portion of the cardiac cycle, comprising about 0.6 of it. Diastole is followed then by a period of contraction called systole, where the heart is contracting and pumping blood to the tissues and organs of the body. Two more points to be aware of are that when the heart is contracting, pressure is increasing, and relaxing, pressure is decreasing. This diagram here is known as Wigger's diagram and represents the cardiac cycle for the left ventricular function. There are 6 curves, and the first 3 show changes in left atrial, aortic, and ventricular pressures. The 4th curve shows changes in the left ventricular volume, and the 5th shows the relationship of the ECG to cardiac cycle events. The 6th curve is the phonocardiogram demonstrating heart sounds and their occurrence during the cardiac cycle. This yellow portion of the diagram is a phase we call mid to late diastolic filling. Here, the blood from the atria is passively filling the ventricles. The mitral and tricuspid valves are open, allowing blood to flow from the ventricles, and the semilunar valves, aortic and pulmonary valves, are shut. Ventricles are near completely filled and the atria contract, causing the P wave here in the ECG. We see this reflected in a small increase in volume in the ventricles also. So when you go to ventricular volume, there's also a small increase here. When the pressure in the ventricles exceeds that of the atria, the mitral and tricuspid valves shut, preventing backflow of the blood to the atria. This is heart sound 1, and that's really important to remember that the closing of the mitral and tricuspid valves equals heart sound 1. The next phase highlighted in pink here is one that is called isovolumetric contraction. Basically, this means that for a brief period the ventricles are contracting and without any change in volume, hence isovolumetric. AV valves, the mitral and tricuspid, and the semilunar valves, pulmonary and aorta, are closed. So to remember that all the valves are closed during this phase, recall that there is no change in volume, so therefore the valves must be closed as blood can't escape. Eventually, when the pressure from the ventricles increases and exceeds that of the pulmonary artery and aorta, the pulmonary and aortic valves open and blood is ejected from the ventricles. This phase here, highlighted in green, is known as rapid ejection. Once the blood has neared emptying from the ventricles, the pressure in the ventricles lowers again below that of the aorta and pulmonary artery, and so the semilunar valves close, creating heart sound 2. For a brief period known as isovolumetric relaxation, highlighted here in orange, all the chambers of the heart are relaxed and all valves are closed. Then the whole process starts all over again. Finally, just to focus in on the relationship between the ECG and the cardiac cycle. So, as we've stated before, the P wave represents atrial depolarization. This is followed by atrial contraction, which is mirrored by the slight increase in pressure in the atrial pressure curve seen here. About 0.16 seconds later, there is a formation of the QRS complex, representing ventricular depolarization, as the action potential has reached the ventricles and causes them to contract and increase ventricular pressure. As a result, the QRS complex begins slightly before the onset of ventricular systole. Lastly, the T wave represents ventricular depolarization, where the cardiac muscle begins to relax and begins slightly before the end of ventricular contraction.